This tutorial is going to demonstrate how to deploy a Django web application using AWS CloudFormation and Docker Compose. So first off, head over to the GitHub repository, and we can see in the root directory here that we have our HTML pages and static images for our Django website. In addition, we have our Docker file for creating the Docker images and building containers. We have our full stack for AWS resources. We will explore this template in a bit. A Docker Compose script, and then a project commands file which can help automate the process. And here you can see the list of commands that we'll be using in the terminal. And of course our requirements text to set up all of the necessary packages for our web application. Also included on here, I put in a README file which can give detailed instructions step by step of how to go about this deployment. Okay, so first off, let's just clone the repository on our local machine. So let's do a git clone. Okay, then a quick ls geocode. Okay, so there we see all our files from our GitHub. Now we're on our local machine. And the first step, according to our README file here, is to go onto our EC2 management console and create a unique key pair for our instance. So we'll call this one comp demo. And we're going to save this file in the project directory that we just git cloned. Have it to downloads. So here's our directory, and we just paste this PEM file in here. Perfect. Okay, so the next stage, we go back into our favorite text editor. So I'm using Atom.io. So here's our AWS CloudFormation template. GGO full stack, typically written in JSON or YAML. And here we're using the GGO full stack written in YAML. So at the top of the script, we have our AWS template format version. So this is the standard. And then typically these have 7 sections, these CloudFormation templates. But for this web application, we're just going to use 4. We have the description section, a parameters section, which is going to outline certain parameters that we're going to use for individual runs. And in this case, we're going to put in our, we can do it right now. We'll put in the name of your key pair that you just downloaded, so comp demo. Here it outlines the instance type T2 micro, in the AWS region, US East 1, and then the availability zone 1A. The next section is our resources section, and here's really the meat of the AWS template. So we're going to outline our EC2 instance, or our compute engine, our storage in terms of S3 buckets, elastic IPs, and for this template we specify auto-scaling groups and CloudWatch alarms. So with the EC2 resource, we're going to, in the properties section, we're going to outline the availability zone, the Amazon AMI, the machine image, which is a Ubuntu server, free tier eligible, the instant type. A good thing about YAML scripts, we can refer to other parameters above. So right here we're going to refer to the instance type above. Alright, sorry, T2 micro right here. And then the key name, which is unique to the user. We're going to outline the security groups, and then finally the user data, which essentially installs Docker on our EC2 server. Within our security group, we're going to open up port 80 for HTTP, 22 for SH, and 2375 for the Docker daemon. Another resource we're going to create is the elastic IP address. So one of the main advantages of Amazon EC2 is the ability to start, stop, create, and terminate instances at any time. But that flexibility creates a little bit of a challenge with IP addresses. So if we restart a stop instance, it results in a new IP address. So to counteract that, Amazon came up with the elastic IP, which provides like a single IP address that can be associated with different EC2 instances over time. So if an instance was ever to be stopped or terminated, the elastic IP can immediately be associated with that new EC2 instance. And the end result is that the web map application or the web application you're running, it won't be disrupted because the applications will see the static IP address that they were expecting, even though the backend EC2 instance has changed. So it becomes very useful when deploying cloud resources. Now we look at the next one, which is our DB instance, and we're using the Amazon RDS in the Postgres engine. So in the properties, we outline our username, password, our DB instance class, which is T2 micro, and we're allocating 5 gig storage. We're also going to create a security group, and then a security group ingress. We're not going to specify any ports for this, so it'll be open to the public. So in order to cope with differential traffic demands over time, by deploying an auto-scaling resource, it allows for the number of Amazon EC2 instances to be scaled out or increased during demand spikes, so when a lot of people access our website, to maintain the performance, and then automatically scale down during traffic downtime to minimize costs. So when we look at what we deploy here, first we're going to create the auto-scaling group, reference the availability zone, and a launch config, which is outlined below. And the minimum size is 0, so we don't want any deployed at first. Just going to have our main or primary EC2 instance, and the maximum size we go with is 2. So how does the auto-scaling group works? They work in terms of policies. So typically auto-scaling policies work in pairs, scale up, scale down. So they can be either demand-based, they can change in percentage, or they can be fixed-based EC2 instances. So we've created a demand-based one where we're going to change in capacity and adjust EC2 instances by 1. In terms of scale down, we're going to do the reverse and scale down by 1 EC2 instance. So how are these policies triggered? They're triggered by CloudWatch alarms, which help monitor in this case the CPU utilization of the EC2 instance. So right here, when we look at this CloudWatch resource type, it basically outlines that to create an alarm, if the CPU usage exceeds 70% for more than 60 seconds over an evaluation period of 3. So when that's greater than that threshold, it's going to trigger this scale up policy, which will then adjust accordingly to an extra EC2 instance scaling horizontally on the cloud server. And conversely, we'll create a CPU alarm for low, so we can minimize costs during traffic downtime. So in this case, when CPU usage is less than 20% for 60 seconds over the same evaluation period of 3, we'll then take away or we'll drop in the EC2 instance, so we'll go back down. And then our launch configuration, so when we're actually scaling up, it's going to launch another EC2 instance with the same Amazon machine image, the Ubuntu server. We're going to use the same key pair that we outlined for the GGO instance, and the same security group, and it'll have the same Docker installed on it. Okay, so when we're looking at the S3 bucket resource, so when storing static website assets or HTML scripts or CSS style sheets, S3 bucket is ideal for this. It's like an object storage that Amazon provides. So right here, we're just going to create a simple one, name the bucket, geogo static, and then we're going to create a bucket policy. And essentially, it's going to refer to our bucket above. Here's the ref. And then the actions that we're going to allow is for users to get objects from it, right? But best practices when working with S3 is that we should provide some AWS credentials, that is key access ID and secret key. So instead of using your root credentials, best practices state that you should create an IAM user that is only allowed to publish or to access this bucket. So that's what we have here. We're going to create an IAM user, and we're going to create a policy document which allows them to access this S3 bucket, and then we're going to publish the credentials, that is the access key. So why do we want to publish these? Well, in our next section here for the outputs, we're going to need these credentials in our subsequent scripts over here. So we need to publish them from our console and copy and paste them into our scripts here. So that's why the good thing about CloudFormation templates, they have these 7 sections, and the final section is the outputs. So we can generate this, and it really helps the process move along faster. Okay, so once that's completed, we can head over to our terminal and we'll look at the commands that we had from our repository. Project commands, I believe it was. Still a cat. Oops. Okay, so now we can just copy the first line here. Oops. Nothing to edit, just double check it. So we want to have the AWS CloudFormation. Oh, make sure you have AWS, the CLI installed, obviously. We're going to create a stack. We're going to call the stack name GGO stack in this case. We have to put this extra variable here, so we have the capabilities, capability IAM, because we're creating an IAM user. We just have to explicitly state that. And then the template body file, we're going to direct it to our GGO full stack in our project directory. Hit enter. Head over to our console in our CloudFormation section. So yeah, just search CloudFormation. Be in here. Alright, and here you see the stack being created. Create in progress. We head over to Resources tab. We're going to see all the instances that they're creating. We're going to see the DB instance, our launch config, security group, S3 buckets. Hit refresh. So this will take a while, maybe 5-10 minutes, around there. So yeah, so we'll resume once this is created. We'll resume and we'll start to take out the outputs as I just outlined. We're going to grab the outputs. We're going to grab some endpoint nodes and just stuff that will be customized for our user project on our local machine. Okay, so our GGO stack has been created. We can check here. Everything's green. Green is good. So our bucket policy, our CloudWatch alarm, EC2 instance, our RDS is there. So everything's good. So the first thing we're going to do is we're going to grab this these outputs. Like I said before, we had the S3 access key and the S3 secret key for that IAM user we created. We're going to copy this. Any text editor, we can just throw them in. We're going to copy this guy. Okay, so while we're on the console, we're going to head over to our EC2 instance. We're going to grab some information from here. So click on running instance. There's all one there. Okay, so our T2 micro is running. We can double check our security group. Check our inbound tags. There, everything we specified on the template is there. Access for HTTP on 80, SSH on 22, and then our custom TCP rule for the Docker. Okay, so first thing we're just going to do is copy our public IP, which is our elastic IP in this case. And then we put it in here. And then we're going to grab the public DNS as well. Throw it there. Save. And finally, we got to go get our RDS endpoint. So head over there on the console. I think we did 5 gig, yeah, 5 gigs. So there is the allocated storage, 5 gigs. I think that's the minimum. Here, DB instance. And we scroll all the way down. You can see our database name, our username. Everything's using the Postgres SQL. And here's what we want. We want to grab this endpoint. Copy this. There we go. Okay, so now that we have all of our user specific information, we can then go back to our script. And first thing you want to do is open this .env.example file. So one of the key things here is that because we have such sensitive information, we need to, well, for one, it's not advisable to publish it to a public repository. So in this case here, we can use both environment variables, or we can use the Python library Python decouple, and that's something we specified in our requirements text there. So how Python decouple works, it searches for a .env file. So right now, the first thing we'll do is just rename this to .env now. And basically we're just going to substitute our user-specific information that we just grabbed into here, and essentially when we run our install our Django application, it's going to then take all these variables and input it into our code. So let's grab this RDS. We'll grab the access key IDs. Put that in. And then the secret key. Our PG password was there, debug true. Oh yeah, and occasionally for the Django secret key, most Django projects, they also have a secret key. Here, I'll show you. If we go into my site. Yeah, so right here, this is how Python decouple works. So we, from decouple, we're going to import the config and CSV. So for example, for the Django secret key, config Django key, and that's going to specify Django key from our .env file. Similarly down here for our AWS S3 specific information, config AWS S3 access key ID, that's always specified over here. So in all, it's like a decoupling process. It's very helpful when working with sensitive information. So all of this should be good. Save. Close these up. So for our Django secret key, here's an optional step that you can use. If you head over to miniwebtool, this one, .com, you can generate a random secret key for Django. So this will be project specific for your application. So we can just copy this, head back over, paste it in, save. There. So now our .env file is all set. So anything we read from our Django settings, anything we have referred there, or in our Docker Compose, anything that's referred, it's going to first look for this .env file and substitute these variables in. Great. Okay, so let's look at our Docker Compose script. So here are the services that we're going to create, and first we're going to create a container called Django Web. It's going to pull from our image on DockerHub, Jesse CNS, GGO, or Django. So when you're doing yours, you're just going to swap out your username right here. The command on running the container is going to launch is going to be python manage.py run server. And the ports that we're going to do, the host is going to listen on port 80, and the container is going to open up on port 8000. In terms of the environment, we're going to now specify those variables that we had. So we're going to name it GGODB, which is from our CloudFormation stack. Our username, Postgres. And then these are the sensitive variables that we had. Our Postgres password, and then our RDS hosts, all of which were specified in our .env file. Okay, so once that is sorted out, that should be good. Let's take a quick look at a Docker file. So we're going to use a Python parent image. I believe they used to have a Django base image, but I think they just focus on this one now. Create environment, Python unbuffered. We're going to make a directory on the container. We're going to put it in var projects conf-final. Then we're going to specify that working directory. Then we're going to add all of our requirement text. So Django, pgadmin, boto3, Django storages, and that Python decouple. We install all of that, and then we're going to add the current directory's contents. So what we have on our we're going to add all of this content is going to be added. And then finally we're going to expose port 8000 on the Docker virtual network. So a very simple Docker file, and everything should be set here. Okay, let's head over to the terminal. Okay, so once again, if you don't know the Docker commands that well, you can just do a cat project commands.sh and then you can just copy my commands that I wrote out here. There we go. So now we're starting to build this image. It's going to install all of our pip install requirements. That's our Django, our pgadmin, our bot03. What else was in there? Django storages. Yeah. Oh yeah, Python decouple was in there. Shouldn't take too long. There we go. Perfect. Okay, so the next step, we're going to do a image tag. Image tag ggO Django. We're going to tag it to our DockerHub name. We're going to call the same file. And then finally, we're going to do a Docker push to our user DockerHub ggO Django. There we go. So essentially, once this is complete, we can head over to DockerHub and hit a refresh, and it'll show up in our repositories here. Alright, so our image push is completed. So as you see, it's right here on our repository. Let me see our tags. A few seconds ago, size. And you can also delete and clean up and, you know, explore it. It's pretty cool. Okay, so there, I did forget one thing. We do have to change one more variable in here. So in our proj commands, I want you to swap out your EC2 instance IP address. So remember our text file that we had, that elastic IP, copy that, and let's just bring it in here. Hit a quick save, right? Because we're going to run this command right now. And what this is going to do is export our Docker hosts to that EC2 instance on port 2375, sorry. Okay, so now we can do a cat proj commands. Right, so now we have that EC2 instance there. We're going to export the Docker host, just so we don't have to keep typing the IP address for each compose command. So we export. Make sure you have that port specified there for the Docker. Right, and then now we're going to run this command here. So Docker compose. We're going to specify the Docker compose script. We're going to run. We're going to create our Django web container, and then we're going to override the default. Look at here. You see the default command was set to be manage.py run server. We're going to override that now with collect static to collect our static files for the Django web app. So here we go. Hit enter. Right, so you see it's grabbing our Docker image from DockerHub. And then it's going to pretty much build our container. It shouldn't take too long. Right, when prompted here, hit yes, and it's going to collect the static images. I think it's about 125 or something like that. Yeah. Okay. Alright, so now we can migrate our database tables. So we do a docker compose, specify the file, docker compose.yaml. There we go. Okay, so everything is migrated. Perfect. Now we can just run a docker compose, and then we can docker compose up, and we'll run it detached, and get our container running. Perfect. So before we check our website, we can do a docker ps. And here's our container ID. It was built using this image that we created. It's running the default command of manage py run server. Create 8 seconds ago. Our host is listening on port 80 and port 8000 is open on our Docker container and it's given a default name. We can also look at our Docker network ls, and you can see they made using the bridge driver, made a Docker network for the application. So that's good. So now we can finally go on, create a new tab, and remember the public DNS we had. Copy that, and we will see our app running. Perfect. So here's the home page of the Django web application. Some general information about the product that we're describing. Some sidebars. A little carousel here made with Bootstrap. Cycle through some of the images, and they're from our S3 bucket, and we could double check that, inspect the element. And here we go. There's geogo static name of the bucket .s3.amazonaws.com life-size pelican.jpg. So there, we know our bucket is functional and up and running. Just exploring here brings us back to the home page, our pricing page, subscription plans. The user could then select whichever plan he wants. Then we go from basic, professional, enterprise. You know, different features. You know, as you scale up, you get more features, more. In this case, they get up more EC2 instances, more geo server. You know, higher database storage capabilities, more customizable. You know, there's a login page, right? If you're not registered yet, click here. It redirects us to a register page. So in this case, let's create a user. Test this out. So Tosin Abassi. First name Tosin, last name Abassi. Let's call it abassi@mail.com. Abassi. Password. And the good thing about using Django as a web framework is that they have a built-in user authentication system. So when you're creating a Django website, basically all these parameters for password and required characters for username, these are built in. So it's just minor customizations you have to do to suit your product needs. So we hit register, save. You have successfully registered, and there's a redirect to a subscription plan. So now we're not forcing. Now the user is encouraged to subscribe for a package. And in this case, Tosin wants the most expensive package, Enterprise. Select your subscription plan, and let's call it AL Incorporated. Save changes. Your subscription plan was successfully updated. And there we go. You can go back in, edit. Say he wants to downgrade his plan, he can now go to professional, basic, and save his changes. If he wants to change his password, click on here, and that's just like the user customization, like, you know, interacting with the website, and that's how the app runs. So now, one thing about Django, they have the admin page. So you are authenticated as Tosin Abassi, but not authorized to access this page. So one good thing about Django is you can create a super user from the terminal. And in this case, because we're running a Docker container on an EC2 server, we can then use a docker exec command. And we can go sudo tty into it. We're going to specify the container, which is 42D right here. So 42D. And then instead of running manage servers and run servers, we can do a bash command and get in there. So now we're within the container, and we're going to run an administrative task. So we know we can go to ls, and here's the manage.py file. So we can simply run a Python manage.py, and then we're going to create a super user. and that user will be able to access the Django administration page. Alright. Username, let's call it me, cns@mail.com, give it a password, confirm password. There we go. So we can hit exit, and we're out of the container, and check this, container's still running. So with that exec command, we're able to go into the container, create a super user, exit the container, container's still running, and now we can Jesse CNS password, and here's the Django administration page. Alright, click users, and there's our first user we created, Tosin Abassi. And these are all, there's his extended user profile, which is something that we customize when creating this web application. Subscription plan choices, company. So now we can view the site as the admin. I could put my name down, Johan Jesse. You know, maybe I'll just get the basic plan for today. CNS limited. Save changes. There we go. I can log out, and yeah, so that's how you would deploy a Django web application using AWS CloudFormation and containers using Docker. So that's the end of the tutorial, and if you have any questions or you got lost along the way, you can always come back to the README file and then just follow on here. The instructions are quite explicit, so they'll get you to the end. And here's the optional commands that we had there with the exec commands, so you can follow that as well. Okay, thanks for watching.